Okay, hi everybody. This is Notes for Homework 68. This is an introduction to function notation. So remember back where we said that domain were the x values. So the domain was known as the x values, and they were also known as the input values. So what's going into the machine are your x values, right? They're your domain. And remember, what's coming out is your y value or your range. So remember, your y values is your range, and those are also known as the output values. So basically, we can write what we call XY notation. So remember that this is called the rule. So x divided by 2 plus 1 is known as the rule of the function. And then what machine are we using? We're calling this one the F machine. So this one is the F machine. So we have the rule and we have the machine. So we can write this two different ways. A long time ago, we didn't teach function notation until we got to much higher level mathematics like Algebra 2. But now we are starting to teach function notation even in early Algebra 1. So prior to that, we would just basically say that to get the output, so we would say to get the output, you would do the input divided by 2 plus 1. And that's how you would say what we were doing. Remember, we were just picking numbers and we were dropping in numbers into the machine and doing x divided by 2 plus 1, right? We were actually doing that math and then a number would come out. Well, that's how you would write that without drawing the picture. Now we're using what's called function notation. So that is known as, for lack of a better term, XY notation, where you're just using the X and the Y. We want you guys to start learning what we call function notation, which is just the same thing. It's just a fancier way of writing it. So instead of writing Y for the output, we're going to say this is the F machine. So we're going to call this, right, because this is the machine that we're using. So we're using the F machine and we're putting parentheses and we're going to say that what is going into the machine. So remember, this is going to be describing what is going into the machine or the input value. And then to get out, we're going to use the rule, take your input, divide it by 2 and add 1. So the X by itself is the input. So this is just a fancy way of writing that. So, and it takes a while to get used to it. After a while, you start understanding the notation and you get used to it. So basically, X is going in and F of X is what's coming out of the machine. That's the output. It's just a fancy way. So this is really just a fancy way of saying Y. So this is just another way of saying Y, saying the output. And then you have your rule of the machine. And then your X is what's going into the machine, right? So F of X and Y are just the same thing. Notice that the second one, the machine, we're calling it the G machine. And the rule is just a simple input. So in other words, whatever you're putting into the machine, you're going to get the same number out of the machine. So we just say to get what we get out of the machine is X. What we get out of the machine is X. And then for the fancy function notation, remember this machine is called the G machine. So this is G of X, is how you read that, equals just X. So you don't read this G times X. I know, it's so confusing. Like we have trained you, right, that when you see a variable next to another variable or with the parentheses, that means to multiply. And now we're saying, no, in this particular context, that's not what it means. So that does not mean G times X. G in this case is just a fancy way of writing the particular machine. It's kind of like having your name, Mrs. Flores, Mrs. Wheelock, Mrs. Lawler, Joey, Sally. It's just you're naming that type of machine. And the type of machine is called the G machine. So again, this is your rule So this is your rule. That's where your rule goes. And then this is the type of machine we're using, which is the G machine. So we read this G of X. And then this is is what's going into the machine, right? So this is saying basically what's going in is also coming out. So you read this, G of X is equal to X. Like that's how you would read it. You'd read it with an of. And that means what you're putting into the machine, so that's your input, and that's your output. So let's look at the next one. The next one is just a number 5. So you have numbers going into the machine, which are your X values, right? Whatever's going into the machine, that's your X value. It's always going in. And this particular machine, we're not doing 5 times the input. We're not doing 5 plus the input. We're not doing 5 divided by the input. So what are we doing to the input? We're not doing anything to the input. Numbers are just being put in, and this is just saying that 5 is coming out every single time. So this is called a constant type machine, or we don't use the word machine, we call it a function machine. And this machine is called the G machine. So this machine is this machine is the H machine, and it has no X. That is called a constant function, and that's kind of a special type of machine. So for the y-axis, we just say to get the output is 5. So the output is always 5. So for the fancy function notation, we'd say h of x equals 5. So the rule always goes on this side. So the rule in this case is just 5. So 5 is always going to come out. That's the rule no matter what. Right? So remember, this is called the rule. This says no matter what you put into the H machine, so no matter what you put into the H machine, you're always going to get out a 5. And which machine are we referring to? We're referring to the H machine. Okay, so this is something you have to practice more and more. So hopefully you're coming to Zoom. And then the next one, we're talking about the P machine. So this time the machine is P machine. Negative, so you can think of that as a -1 times the input plus 2. So -1 times the input plus 2 is the rule. So -1 times the input plus 2, that is called the rule. Sometimes they call it the equation. So could be called the equation, the rule. So we're saying, remember, y is what comes out of the machine and x is what goes into the machine. So we can say to get something out of the machine, you're going to do negative times whatever the input is and add 5. And that's called the XY notation. And now, in the new Algebra 1, they want us to go a little bit deeper and they want us to show the function notation. It's just a fancy notation. So we're going to use, since it's the function p, we're going to say p of x. That's how you read that. P of x. You read that p of x is equal to, and then we put the rule down. And the rule was -1 times the input plus 5. That was the rule. So the rule goes on this side. So this basically just says no matter what you put into the machine, you're going to do negative times that input and add 5. So this is your input. And when you do this to it, then you're going to get your output. So just being able to take a picture, a diagram of a machine, and write it in XY notation, input-output notation, and then to also write it using this fancy function notation. So that's what we're going to go over today, some fancy function notation. So let's look at the next. So on the next slide, it says, basically we want you to practice reading this. So in number 5, like, how do you read that? You don't read that G times 3. So this is not read G times 3. That is read G of 3 equals 12. Like, that's how you read that. That's how you read it. But then what does it mean? Right? That's how you read it. But what does it mean? So this means that when you plug 3 into the machine, you're going to get 12 out of the machine. So it means 12 is the output when 3 is the input into the G function. You can also rewrite it. You can rewrite it that way, or you could say that when 3 is the input into which machine? The G function, 12 is the output. Basically, what's going into the machine and what's coming out. So basically, you just need to know that 3 is going into the machine and 12 is coming out. Some kids will say 12 is going in. Nope, 12 is not going in and 3 is coming out. So this is your input, and this is what's coming out of the machine. So knowing which one's the input and which one's the output. So which one is the input and which one is the output. So you can write this either way. You don't have to write them both. So you can say 12 is the output when 3 is the input into the G machine, or you can say 3 is the input into the G machine and 12 is the output. Doesn't matter which one you write, you just have to write one of those. So I'm just going to leave it with that one. And then for number 6, like, how do you read that? That is read H of 24 equals 1. So that does not mean H times 24. Remember, that does not mean H times 24. This is a different context. This is function notation, and it does not mean H times 24. We're referring to a particular machine, and we're calling it the H machine, right? And we're saying when you put 24 into that machine, you will get 1 out. We don't know what the rule is of that machine. Right now, we don't know what the rule is of that machine, but we do know that if you plug 24 into the H machine, you're going to get 1 out. That's what we know, and that's what that notation means. So can you just describe what it means and how to read it? So this is how you read it, and then what does it mean? It means, you can do it both ways. You can say, when 24 is the input into the H function, 1 will be the output. So just understanding what the notation means between inputs and outputs, and the G and the H does not mean G times 3. It just is describing the name of the machine. Okay, so let's look at the other questions. Okay, so let's look at the directions. It says use the following functions to find the output. So we're going to find the output given the input. Show your work and write your final answer in function notation. So your final answer has to be written in what's called function notation. Make sure you use the correct function machine. So let's look at the different machines. So notice that we have the machine F, we have the machine G, we have the machine H, the machine P, and the machine Q. So basically we have different machines. We have the F machine, and its rule is negative 2x plus 1. We have the G machine, and its rule is negative x. And we have the H machine, or H function, and its rule is take the input and square it and add 1. We have the P machine, and the rule for that is -6 plus 1/2 times the input. And then we have the Q machine, which just says -3. So, right? So we're doing it without pictures. So we're looking at it without using pictures. So let me get rid of the pictures. So in problem number 7, it says find h of -4. So which function are they asking us to plug -4 in? Correct, the h function. So we're plugging -4 into the h function. So that means we're using this one. And remember, this is what's going into the machine. So we have to put -4 where the x is. So this is how you're going to show your work. You're going to say h of -4, and then the machine is the input squared plus 1. So we're going to do the input squared plus 1. So they want us to put -4 into the machine. Don't forget you have to put parentheses there, and then you do PEMDAS. Order of operations says you do exponents first, so -4 times -4 is positive 16, and 16 plus 1 is 17. So when you plug -4 into the machine, didn't we get 17 out? And that's how you write your statement, because that's what that means. It means when you plug -4 into the machine, we got 17 as an output. So look at number 8. Number 8, which machine are we going to use? Right, did you say the P machine? So this time we're using the P machine, and aren't we putting 10 into the machine? So the P machine is, this is the P machine. So now we're using this machine. So we say P of 10 and then equals -6 plus 1/2 times the input. So -6 plus 1/2, and then remember, they want us to put 10 into the machine, so 10 goes where the x used to be. Right? So 10 goes where the x used to be. And then we do order of operations. Order of operations says you multiply first. So 1/2 times 10 is 5. And then -6 plus 1, 5 is -1. So you get -1 out of the machine. So basically, if you took the P machine and you drop 10 into the P machine, you're going to get -1 out. So if it's just input output. So if you drop 10 into the machine, you're going to get -1 out of the machine. And so this is the notation that says that. So we're going to go back and write P of 10 equals -1, because that means that when you plug 10 into the P machine, you get -1 out. So it's just inputs, outputs into a particular rule or function, and then we're just naming it either the P machine or the G machine or the F machine. And it's just understanding the fancy, what we call it. We call this function notation. So this is known as function notation. It describes what's going into the machine and then what's going out, coming out of the machine. And then it describes which machine, the name, or which machine you're using. So let's look at number 9. In number 9, what machine are we using? Let's get rid of this one. So in number 9, which machine are we using? Did you say the G machine? So that's this one here, right? And what are we going to put into the machine? Is we're putting -9 where the x used to be. So we're going to show the work. So we're going to say, so part of it is not just getting the output. Part of it's also understanding how to write your notation. So it's not about just what is the output, but it's also about, do you know the correct way to write your notation? So G of -9, remember that doesn't mean multiplying. Read that, G of -9 equals, and then I'm just copying down the rule. It says negative times the input. So that means we have to do G of -9, and where there's an x, I have to replace it with -9. So I'm going to replace the x with -9. So that gives me a negative, and then I put a parentheses 9. It's always smart that when you're going to insert something to put a parentheses around where the x value used to be. I just want to emphasize, notice that there was a negative in front of the input. A negative in front of the input. And then isn't a negative times a negative a positive? So when I put negative 9 into the machine, doesn't a negative times a negative, doesn't that give me a positive 9 out of the machine? So when we put negative 9 in to the G machine, we got positive 9 out of the machine. So hopefully you understand what the notation means. And then number 10, we're going to plug 6 into the Q machine. So when you're doing your homework, make sure you're using the correct machine. So the Q machine is this one. And notice there is no x. See how there is no x? Do you remember? That's called a constant function. So what that means is we have the Q machine, Q. Let me rewrite that. That looks like a G. So we have the Q machine. And the Q machine, the rule for the Q machine is just negative 3. That is called a constant function. There's no x. It doesn't say negative 3 times x. It doesn't say negative 3 plus x. It doesn't have an x at all. So that is known as a constant machine. There is no x. So remember, that means no matter what you put into the machine, no matter what x value goes into the machine, negative 3 is always coming out. So when Q of 6 is going into the machine, negative 3 is coming out. That one, that's it. There's nothing else, just understanding that it's a constant function, and no matter what you plug into that machine, so no matter what you plug into that machine, you're always going to get negative 3 out of the machine, no matter what. So if you were to say, I'm going to plug in 7 into the machine, you'd still get negative 3. Well, what if you plug in 0 into the machine? You're going to get negative 3. What if you plug in 5 into the machine? You're going to get negative 3. What if you plug in negative 2 into the machine? You're going to get negative 3. No matter what you plug. No matter what you plug into the machine, you're always getting out a negative 3. That's what a constant function is. Okay, so that was our answer for that problem. And then last problem. Last problem says find f of negative 3. That's how you read that. It says find f of negative 3. So which machine are we using? We're using the F machine. So we're using this one up here, the F machine. And we're going to put negative 3 into the machine. So the rule for this problem is negative 2 times the input plus 1, and we're going to drop a negative 3 into the machine, and we want to see what comes out of the machine. So we're going to say f of negative 3, and we're going to recopy the rule, right? And then we're going to plug in place of x. We're going to put negative 3 where the x was. So it's negative 2 times the input plus 1. So you have to write that out. Negative 2 times the input. You got to put a parenthesis to show multiplication. Order of operations, you got to multiply first before you add. So when you plug negative 3 into the machine, we get 7 out. And we want your final answer to be written in function notation. So that means you would have gotten 7 out. So when you plug in negative 3 into the F function, you would get 7 out. So input, output, using different functions, and you have to make sure that you're using the correct function. Go back and rewatch if you need to. Maybe pause a video and try it yourself before you look at it. So you can always go back and rewatch a video and pause it and say you're going to do it. And then you can write the answers and then play it to see if you were doing it right. And you can move it forward and go to another problem and say, okay, I'm going to pause it, try this myself. And then you can do it, and then you can play it to see how you did. So that's how you can use a video to help you learn.